Hi everyone, thank you all for joining us this Friday evening for what promises to be a really exciting talk. We're very grateful to have Laurie Hannigan joining us this evening. A few words, I'm not going to take much of your time, but Laurie is a senior researcher based at the Lovisenberg Diagonal Hospital at the Norwegian Institute of Public Health in Norway. And he is now co-leads the Psychiatric Genetic Epidemiology Research Group over there. And he also holds an honorary research associate position at the MRC IEU at the University of Bristol. His research interests include studying within family transmission at risk for psychiatric disorders, which he's going to be talking about today, the etiology and development of emotional and behavioral problems, factors influencing the emergence of neurodevelopmental conditions, patterns and consequences of comorbidity and multimorbidity, and methodological issues in the application of developmental genetic epidemiological approaches to birth cohort and population registry data sources. Most of your work is on the MOBA data set, right, which is this large Norwegian mother and trio-based data set. And before that, you were at King's College London, where you did your PhD working on the TED sample. Is that correct?
Yeah.
Great. With that, thanks again very much, Laurie, for joining us, and looking forward to your talk.
Yes, so thanks, Varun, for the introduction and for inviting me here. I told you earlier that I've sort of learned something important from this interaction, which is if you want someone to do something, invite them 1 year in advance, because it's impossible to say no 1 year in advance, really. You can't say, I'm busy that Friday. But I'm really happy to be here, and it's been really interesting. I've met with a few people here, and I'm really happy to get the opportunity to come and talk to you about some of the work that we've been doing and what I think is an interesting area of research, sort of, trying to look at intergenerational transmission of psychiatric and neurodevelopmental conditions. So I will talk. I'm happy to be interrupted if you want. There's kind of nominally 3 sections to the talk, so I can kind of pause in between and take any questions, or I gather we have plenty of time for questions at the end, so please feel free to interrupt me if you like. So a bit of further background. This is not me, but Google would tell you that this is me. This is Elsie van Bergen from the Netherlands. I feel bad for her that she has been confused with me in such a way. So yes, other than the fact that I'm not Elsie van Bergen, I have nothing else relevant to disclose for this talk. But what I am going to talk to you about is, first of all, I mean, you're here, so I guess there is some interest already in like what the study of intergenerational transmission. So maybe we won't spend too long on trying to persuade you that this is kind of an interesting thing to look at. But I'll start there, and then I'm going to provide a kind of heavily curated tour of some of the approaches that one can use to study intergenerational transmission of psychiatric and neurodevelopmental conditions, and present some of the evidence that we've generated mainly from MOBA data. And I'm kind of uncomfortable doing it where I sort of imply that the only kind of interesting work that's being done is from one particular group on one particular sample. That's clearly not the case. But I feel like there's some justification in that, the MOBA sample is probably less spoken about here than some of the other fantastic UK based and other international samples. So and it's something that I know quite well. So that gives me kind of reason to talk about MOBA. And then I'm just going to kind of zoom in on one particular study to try and kind of walk you through a study of a specific research question in this area, and kind of how we've gone about answering that. Hopefully there'll be something in there for everyone to take from this. So so we're on the kind of question of why investigate intergenerational transmission, and the kind of bottom line of this for me is because these conditions aggregate within families, right? So there's a very long history of research looking at and recognizing this aggregation of these conditions within family members, right back from the first studies of like identical twins and twins, in schizophrenia, and a long history of kind of behavioral genetic research in particular. And I'm kind of not going to go into that now, but I just sort of pulled out a couple of salient examples of kind of research. Ironically, I've got two examples. They're both from Scandinavia, so it does feel like I'm really kind of hammering home this sort of Scandinavian thing at the moment. But this is just a nice study from the registry information in Denmark, where they have information on 3 generations of people, and they're essentially looking here at what is the kind of hazard ratio, what's the kind of risk of receiving these different diagnoses, given that your relative has had a diagnosis. And so you can just see here whether we are looking at parents of individuals who've had diagnoses, or siblings of individuals who've had diagnoses, or children of those individuals. Almost across the board, you're seeing increased risk of receiving, any one of a number of different diagnoses. And this is a pretty consistent picture that we see both within given disorders and diagnoses, so increased likelihood of receiving the same diagnosis as a family member, but also across disorders. And I think the sort of second example I pulled out, this is about the kind of cross-disorder sort of increase in likelihood of receiving a diagnosis with for autism and ADHD. This is from Sweden, and it's just some data showing that essentially if you take an individual who has received a diagnosis of either ADHD or autism, then their likelihood or their odds ratio for receiving the other diagnosis at some point within their lifetime is kind of enormous. But actually that's almost matched by that for a monozygotic twin, right? So if your twin has received one of these diagnoses, then the chance of receiving the other diagnosis is incredibly high. And this sort of risk is sort of stepped down across the familial relationships. But I think it's kind of part of a much larger picture of quite persuasive evidence that also fits with our like anecdotal knowledge of the world, right? Which is that these conditions and lots of the traits and behaviors that associate with them are shared among family members. So if we're okay to agree on that being a pattern in the world, then I think given this aggregation, it's a sort of necessary step to take to ask, well, why do we see these patterns of aggregation, right? And so it can, I think it's often perceived as one of a couple of explanations, but I think I'm going to argue that there is quite a lot of complexity here, and that there are a number of different things we have to take into account when we want to study these questions. So I think this is the assumed relationship for a lot of causal basis for a lot of the observational relationships that are seen in the literature. I think it's kind of historically been the case, and there are some very sort of quite sort of troubling examples from history about the sort of refrigerator mother hypothesis of schizophrenia and autism, where there was this kind of assumption that it was essentially kind of blaming a mother's behavior in early life for diagnoses that would then happen much later. But even away from something that's quite so sort of like direct, I think a lot of the modern literature still makes this sort of default assumption that kind of risk flows in this one direction, and that involves some component of exposure on the part of the child to a parent with a specific condition or with traits that are linked to that condition, and that having some effect on the child, either because it sort of interrupts the kind of the standard kind of parent-child relationship in some key way, or because it involves the child learning certain behaviors and modeling and those kinds of things. I'd imagine that many of you will have thought of possible reasons why that would not be a straightforward relationship, and I think one is shared environmental confounding, right? So if we have some environmental factor that predisposes individuals to have a neurodevelopmental psychiatric condition, and that environmental factor is shared by both parents and children, then it's going to kind of act as this sort of third variable, as they say in epidemiology, right? And sort of confound this relationship. And so if you don't look at this stuff, you just see this middle pathway, and you interpret it in a way that is not actually reflective of the underlying causal processes. And of interest to me in the line of work that I'm in, there's also, I think, a similar pathway with genetic information, right? And here the arrows are slightly different because we know where the genetics come from with respect to the children. But if these genetic factors present in the parents are having are being expressed in a way that influences their liability to receiving a diagnosis, we know for a fact that those genetic factors are being passed on, right? That's kind of a Mendelian kind of fact, that we know that 50% of dad and 50% of mum's genetic material is going to the children. So we only then need to consider the possibility that those same genes increase liability to the same or some other problem in the child generation, to have another pathway by which this central association could be confounded or could appear spuriously. And it sort of gets more complicated than that, I think, as well. So the sort of, in a way, the really obvious pathway that people for some reason don't often think about is that kids may influence their parents' mental health. And like, I have 2 children, and I believe that this pathway is maybe sometimes more than others, like quite a relevant pathway, right? Sometimes they can be, annoying, or more than that, and there can be some kind of, I think quite serious challenges to parenting that can relate, can translate into effects on parents' mental health. Other complexities to this picture: mums and dads' genetics are not as independent as we might think. So because lots of the kind of complex traits and behaviors that we exhibit in day-to-day life have turned out to be under, to some degree, genetic influence. To the extent that you match up with a partner based on almost anything, shared interests, shared personality, similar ways of using language, then the independence of your 2 genotypes is kind of going to be broken as far as those traits are under some genetic influence. And that has implications for this pathway to the children as well. Those genetics can then correlate with the environment, because I was talking about those complex behaviors that we all kind of engage in. Some of that involves deciding when and whether and where to go to university, where you may kind of end up living, and all these kinds of things. So you end up with this kind of complex mess of associations that I think means that we're a long way from this original picture of just kind of like, it's the parents, they have some risk and they pass it on to the kids and we can all go home. And then also there's this kind of other complication, if you like. I don't think this is biologically very accurate, but this is what we're working with. But like the possibility that some risk is actually conferred in utero, right? And this is quite a kind of popular hypothesis in some quarters, that actually behaviors and exposures for the mother while she is pregnant are relevant factors for the child's development later in life. So these are some of the mechanisms that I think we have to start trying to tease apart if we want to study intergenerational transmission. Here, I'm going to talk about 3 sort of groups of methods that we might use, and I'm just going to introduce them very briefly, and it's because it's combinations of these methods from which the examples that I'm going to present are going to be based. So this is not an exhaustive list, and it's not a kind of full introduction to any of these methods, but I'm hoping to give you, for those who are unfamiliar, enough information to kind of then go ahead and interpret the evidence that I'm going to present. So the first of these is family models, and I think this is kind of quite intuitive to most people. What we essentially do with different kinds of family models is to take what we know about genetic similarity between different types of relatives and play that off against what we can measure or observe about differences in their traits and behaviors, right? And so given that we have, for example, in your relationship to your sibling can be either as a full sibling, where you share 50% of your segregating genetic material, as a half sibling, if you only share one parent, where you share 25% of your genetic material, or in some cases as an identical twin, where you share 100% of your genetic material. We can exploit the differences between those relationships and use that information to make to get estimates of the extent to which genetic, but also different kinds of environmental, including family environmental or neighborhood environmental characteristics, are responsible for explaining variation in traits. And when we're talking about intergenerational transmission, we can use that information to sort of also decompose links between different family members into these different sources of variation. Okay, a second set of approaches, or a basis for approaches that we use, is something called polygenic scores. So to some people, this kind of plot might be familiar. This is a kind of Manhattan plot, which is the sort of stock and trade of a particular form of epidemiological research that is kind of very much in vogue at the moment, which is genome-wide association studies. So this is to get very, very large samples of people and look at variation across their genomes and see how that variation is associated with some diagnosis or trait or behavior. And so this tells us something, in an ideal world, this tells us something about the underlying biology of a trait, because these are genes get coded into proteins, and at some point further down, some magic occurs, and then at some point further down the line, these things affect our behavior and our traits. And that's one application, but the other thing that we can do with this information is we can kind of piggyback on these enormous consortia-led efforts to discover the genes associated with things, and actually port that information, what they've learned, into much smaller samples where we still have genotype information on our participants. And the way we do that is essentially, if we imagine there's one allele at this point, so that this discovery that they've made at this point on this chromosome 2 of an allele that's associated with some trait in a GWAS, what it actually amounts to, this is an example for height. So we're sort of saying, okay, this is a GWAS of height, there's this one variant, and if you have 2 copies of the G allele here, then you're 4 centimeters taller than somebody who has no copies of the G allele, right? And so what we can imagine on the basis of that is, we know that there's lots of variation in height. If we look at a bunch of people who have, and line them up effectively according to their height, and we look at this particular allele, we should see, everything else being equal, that we have some people with the 2 copies of the G allele, and they are 4 centimeters taller than some people with no copies, and then there's some people in the middle. So that would be like the effect of one genetic variant at one point in their genome. But of course, we have many, many millions of genetic variants in our genome. And so what a polygenic score does is essentially take this information from every one of these little peaks across the genome and sort of aggregate it at an individual level. So essentially, this could be another allele, another place on the genome where if you have a T allele, then it actually makes you 1 centimeter shorter. So this individual with 2 copies of the T allele will be 2 centimeters shorter, all else being equal, than somebody with no copies of the T version of that allele. So that they also have the original variant that we talked about, so we're in a different version of the genome. So in addition to what they had going on originally, they also have whatever change in their height is conferred by this location on the genome. And so what we're getting, if we kind of do this across the genome, is per individual an aggregated score of how many copies of each risk allele they have, weighted by the specific effect that that allele has. So the second allele we looked at is a -1, and if you have 2 copies of it, then you get -2 centimeters, basically. The other one had a different effect size, it was +2, so 2 copies is associated with a 4 centimeter kind of gain in height. So it's a sort of a long-winded way of saying what we end up with here is an individual level variable which gives us information about that person's genetic liability in the round overall across the genome for a particular trait. And we can use that variable in different ways to look at intergenerational transmission, which I'll come on to. Okay, last set of methods, and then we'll talk about some findings. So Mendelian randomization. This is an approach that is often introduced as a kind of natural analog to a randomized control trial. Randomized control trials being the kind of gold standard way that we get evidence about what causes what. And the way they work as a kind of analog of a randomized control trial is simply that instead of randomly assigning people to treatment groups and control groups, what we rely on is a natural process that is kind of a Mendelian process where alleles are randomly segregated and assigned to individuals as part of meiosis, right? As part of our sort of germination early on in the process of life. And if we go back to the sort of previous slide where we think that we have certain alleles, so the height of these peaks here is related to how strongly associated an allele is with a trait, right? So if we have certain alleles that are strongly associated with a trait, then you can imagine if we just took one of those alleles and we essentially said, all right, let's group the population into those who have 2 copies of that allele and those who have no copies of that allele. Although we haven't randomized them, nature has randomized them in terms of whether or not they have 1 or 2 or no copies of that allele. So if that allele has an effect on something that could be an exposure of interest for us, then we've got the kind of randomization that is equivalent to a randomization in a randomized controlled trial. Okay, I'm not going to go into kind of further detail because it's like it is a kind of a bit of a minefield. In fact, I say I'm not going to go into further detail. I've got 3 slides on the assumptions of this process, but essentially what this looks like in a kind of schematic diagram here is that if you have some genetic variant that is strongly associated with something that you want to test as an exposure for something else, and that genetic variant is not associated with confounders, and for genetics, that's a pretty good assumption most of the time because there's not many things where the arrows go in that direction, right? Because this is happening at conception. And there's no other way for that genetic variant to influence the outcome you're interested in, apart from via the exposure that you want to test. Then you have a scenario where you can test a causal hypothesis about the relationship between 2 things using this method. I'm going to give an example of this method in a minute, and hopefully that will be clarifying. It may go the other way, but it's something we can come back to in discussion if you like. Does anyone have any questions or burning things you want to ask now? Should we just go for it? So one other just bit of introduction. Varun mentioned the MOVA study. So most of the results that I'm going to present are based on the MOVA study. This is a large longitudinal birth cohort based in Norway, where they recruited they invited pregnant women during a recruitment window 1999 to 2009 to take part in the study, recruited them at ultrasound and followed them up and their children up longitudinally. They extracted genetic information from blood samples. And then the other sort of unique part of this cohort that is kind of based on a sort of a degree of trust and compliance in Scandinavian countries that isn't always mirrored in the UK, which I can say because I come from the UK, is that we're able to link the information from these participants of MOBA with these full national registries where information is collected on all members of the Norwegian population in terms of a bunch of different characteristics, basically their health, their education, income, prescriptions. And so this is a really important sort of element of why this is a useful cohort for research. And this is kind of just an overview of what it looks like. And I'm going to be kind of presenting examples from across this time span. But essentially, we have biological samples taken very early from mother, child, and from mother, father, and from cord blood from the child, which allow us to have genetic information on these individuals, and then regular follow-up with questionnaires across the lifespan of the children. Okay, so some examples. This is not meant to be representative. It's just a kind of like a walk through some examples of studying intergenerational transmission using these designs. And we kind of, I've sort of risked bogging you down a bit in the methods, but the diagram to think back to is that one of, you know, the parents, the kids, and the arrows in between them. And so what we're trying to do is isolate different pathways in that diagram. So the first example is based on the family design, right? So based on this idea of using known genetic relationships, observing phenotypic relationships, and using that information to pull apart these different mechanisms. So here we were interested in maternal symptoms of depression during pregnancy. And it's kind of been hypothesized that this is, through this in utero exposure, this is a pathway by which kids' later life outcomes can be influenced, right? And so in order to test this, what we did was take mothers and their siblings and simply ask whether children, on the various kind of traits and outcomes that we're interested in, whether children, for example, of a monozygotic twin mother were as similar to their mothers as they are to their aunts, their mums, monozygotic twins. And then we do that for every different relationship type in the parental generation. So are they as similar to their mother as to their half sibling, as to their full sibling? And we kind of use that information and kind of, you get a horrible looking thing like this, which I'm going to hide immediately. But what it allows you to do is get to this, right? So these are the pathways we're interested in. Hypothesized pathway for some people, maternal depression during pregnancy has a direct influence on liability for offspring having problems, behavioral and emotional problems in their life, which is then manifested after the child is born. Alternative pathways, similar to how we drew it before, mothers pass on genes to their children. We know that if those genes influence depressive symptoms in the mothers and behavioral and emotional problems when expressed in the child, then we have a confounding pathway, and then a sort of additional confounding pathway, which is mothers who are depressed during pregnancy are more likely to be depressed later in a child's life. So if there is some influence, exposure influence through some of those mechanisms that I mentioned, then potentially that also confounds this in utero exposure pathway. So what we found here was essentially that once we account, so the genetic sharing pathway is this sort of loop around the outside here via these A components. And so once we account for that pathway, the phenotypic correlation between these two traits, so prenatal depressive symptoms, offspring internalizing problems, which was a phenotypic correlation of about 0.16, it gets mostly attenuated. So most of the explanation for that phenotypic association is because of the shared genes. There's a little residual association, which is kind of consistent with a kind of causal exposure effect. But as soon as we account for depressive symptoms measured concurrently with the offspring internalizing problems, that effect goes away. So for offspring internalizing problems, we don't find any evidence consistent with an in utero exposure effect. And the same for externalizing problems. This is internalizing emotional, externalizing behavioral problems. So once we account for the genetic pathway here, the known sharing of 50% of genes between mothers and their offspring, then we find no residual association that would be consistent with a causal explanation for this intergenerational link. Okay, so switching methods, switching outcomes. So here we're interested in a question about whether or not maternal behaviors and exposures during pregnancy are a causal risk factor for offspring neurodevelopmental conditions, ADHD, autism. And this is a hypothesized pathway, right? Things that the mother does during pregnancy, way she behaves, what she eats, what she does, are through this in utero pathway, a causal risk factor for developing neurodevelopmental conditions. And what happened in this study is that they looked at whether or not the genetic factors, genetic liabilities in the mothers were associated with those behaviors and exposures, right? So this is asking whether or not that pathway by which genes are influencing behavior in the mother and then being passed on to the kids and then influencing the kids' outcomes. If for the first part of that pathway, we need to know whether or not the genes influence the behaviors in the mother, right? So that's all that was looked at here. That was quite a simple idea. If we take these polygenic scores, and in this case, so it's polygenic, it's genetic liability on the part of the mothers for ADHD, for autism, and for schizophrenia. Are those genetic liabilities associated with some of these factors during pregnancy that are typically seen as potentially causal risk factors? Quite difficult for you to pick much out of this plot. It's quite busy, but ignore the fathers. The fathers are in there for a different reason, which I think is not worth going into now. But if we look at the mother's effects, so this is the effect of mother's genetic liability towards ADHD on whether or not she has smoked during pregnancy. And you can see that there's an increase in the likelihood of mother smoking during pregnancy of about 20% per one standard deviation increase in her genetic liability for ADHD. So if someone were to hypothesize that smoking during pregnancy is a causal risk factor for offspring developing ADHD, while we're not looking at the offspring here, what we can say is that that may be the case, but we know for a fact that the mum's genetic liability is influencing the likelihood of smoking during pregnancy, and we know for a fact that she's going to pass 50% of that genetic liability onto the children. In this study, we don't know what happens next, but you can see how that pathway of confounding could be completed if those genes have a similar effect or have a direct effect on ADHD liability in the children. And this is replicated for a number of exposures for maternal ADHD, not so much for autism, which is partly to do with the nature of that score and how effective it is at predicting variation, and also some exposures for schizophrenia as well. Okay, so last example within the kind of perinatal period now. So another hypothesized exposure for offspring neurodevelopmental conditions is fetal growth restriction, right? So how much they're able to grow within in utero. And so this study kind of combines two of the approaches that I introduced, right? So it's using the Mendelian randomization. So it's finding a genetic instrument that is robustly associated with, in this case, birth weight, and asking whether or not that information predicts offspring likelihood of neurodevelopmental conditions and traits. But, which it does, so this is the observational kind of associations, right? So this is conventional associations between just birth weight as measured and neurodevelopmental trait outcomes. So we can see some quite strong outcomes between autism-related traits and birth weight. So where having a lower birth weight is associated with having higher scores on this measure of autism-associated kind of traits and behaviours, and sort of so on down the list. And these are reasonably kind of strong and robust associations. So one could interpret these associations as a suggestion that birth weight is a causal risk factor. Low birth weight is a causal risk factor for neurodevelopmental conditions. Similar kind of diagram to what we've seen before. We're trying to isolate the pathway that we're interested in that's consistent with the causal explanation that we're positing by accounting for the other possible pathways. So what we're interested in here is mother's kind of genetics affecting the intrauterine environment, and that affecting fetal growth and neurodevelopmental trait outcomes. And in order to isolate that pathway, we have to account for the possibility, among other things, but let's focus on this one, that what's happening is mum's passing on the genetics are expressing in the offspring and then directly having an effect on our fetal growth and on development. And the story is that this doesn't skip. This skips. The story is that all these associations attenuate down to the null when we account for those other pathways. So if it was the case that this was a kind of causal risk factor, then accounting for those other pathways shouldn't have an effect on these associations, but it does. So it's consistent with the idea that this hypothesized causal pathway is actually, or this hypothesized causal association, these associations are actually the product of confounding by other pathways. That's quite a complicated one. So if that hasn't landed, then don't feel bad. Okay, just a few more examples. We're now sort of moving chronologically a bit later into childhood and into the lifespan. And what was done here is Leo took as an outcome conduct problems, behavioral problems in kids in the middle of childhood, right? And he simply asked whether, if we consider this situation, so we've got mum's genetics, we've got dad's genetics, 50% each produces the child's genetics. There are two ways in which mum's genetics can be related to the offspring phenotype, i.e. conduct problems in an 8-year-old child, right? One way is mum passes on 50% of her genetics, and those genetics have a behavioural manifestation, and the child has some conduct problems. And the other way is those genetics express in mum in some way that we're agnostic to in this model. We don't know exactly what's happening, but they express in mum, and then they have a kind of exposure-based effect, right? So you could hypothesize that this is something like the same genes that are passed on to the child and influence their liability to conduct problems lead to more risk-taking behaviours in the mother, and that affects her ability to provide parental care in some way, right? That's a kind of top of my head explanation, but that could be a pathway that someone would hypothesize, right? So there's two ways basically for this influence to happen, by this pathway or by this pathway, and the same for parents. And these pathways in this paper are called genetic transmission, i.e. this way, or genetic nurture, which is a kind of slightly difficult term, but it's the idea that basically via parental behaviors, genes are having an effect on children via a nurturing pathway. I don't love that term, but there we go. So what we see here is in blue, the estimates of that genetic nurture pathway, so that pathway that is like influenced via maternal and paternal behaviours, and in orange, the direct genetic transmission pathway. And what you can probably see is that for the most part, all that's going on is direct genetic transmission, right? So there are some alternate examples here where what this is showing is that the same genetic factors, that is genes associated with cognitive performance, educational attainment, are, when present in the mothers, increasing the likelihood of conduct problems in the children, but when present in the children, decreasing the likelihood of conduct problems. I don't know what's going on there, but there are some oddities with using these particular genetic scores that mean that I think that has to be taken with a pinch of salt. But I think the sort of take-home message here is really that most of the association between the kind of parental genes and the child's behaviours are via this genetic transmission pathway. Okay, I think this is the last but one example, and then we get a break. Not a proper break, I just talk about something else. So this is a nice example of bringing back in the principles of the family models, right? So this principle of playing off known genetic similarity, observed phenotypic similarity, to break down the sources of variation in a trait. And so what Laura did here was to look at early neurodevelopmental traits, things that are related to autism and ADHD, behaviors that are measured that are related to those conditions early in life. And what she did is to run a series of models, right, where the first model allows genetic effects from mothers, genetic effects from fathers, links between those effects, and then we progressively constrain that model to make it simpler, because a simpler model is a better model if it fits the data. So what she found is that if you want to explain variability in childhood attention, hyperactivity, and restrictive and repetitive behaviours that are quite associated with the autism phenotype, then the best way to do that is with a model that incorporates both direct effects of children's own genes and indirect effects via mother's genes. And so you can constrain down this larger model and you don't really lose any fit. If you constrain this model down further and remove the maternal genetic effects, then the model fits the data significantly worse. So, and you can see as well that the indirect genetic effects, so this is actually equivalent in some respects to the genetic nurture pathway that we didn't see much evidence for in the previous study, is actually larger in most cases here than the direct effects of child's own genetics. In contrast, for language traits, motor traits, and social communication traits measured at the same time, 3 years of age, the best fitting model in each case here was just straightforward genetic transmission, so the child's own genes influencing their variability in these traits. And this is just kind of a reminder that that arrow in the middle of the diagram I showed at the beginning doesn't have to go from parents to children. So we can also think about the effects going the other way. So in this example, Ludwig used exactly the same models that I've just shown for Laura. In this case, the outcome was not a child phenotype, but actually maternal depression. So we're essentially asking whether genetic variation in partners and children can explain variation in maternal genetic symptoms, maternal depressive symptoms, in addition to mum's own genotype explaining that variation. And interestingly, that is what he found in a sort of slightly varying developmental pattern, right? So in the early time points after birth, it was sufficient just to include a direct effect, so an effect of mum's own genotype influencing her her depressive symptoms. But as children got older, it was necessary to include these indirect genetic effect pathways. So he wasn't able to separate out whether or not these are effects of partners or whether or not these are effects of children. But I think it is striking, at least, that it's developmentally different. So it would suggest to me that the kind of development of the child into more of a kind of acting, thinking, behaving, misbehaving being is involved in some way here, in explaining variation in maternal depressive symptoms. So that was a whistle-stop tour of some different examples. If somebody wants to ask any specific questions about those examples, now might be the best time, but I'm happy to kind of have a more general discussion at the end, or yeah, as you wish, really. Yeah.
Could you maybe say something briefly about what kind of confidence we have in the association between genetic conditions and specific things like you showed cognitive performance? I never realized we could make those strong connections.
Yeah. Yeah, so just in case anyone didn't hear the question, and tell me if I've got this wrong, but the question is about how confident can we be about these links between, for example, cognitive, the genetic factors and things like cognitive performance, educational attainment. And the answer is that it varies a lot depending on the different traits, right? And that is a really key point. So where we get that information is from these large-scale genomic discovery efforts that I sort of showed and talked about in the beginning. And those are at different stages for different kinds of traits. So, for example, height is a trait where they have got enough information from enough people to be able to explain all of the genetic variation in height that sort of exists with across the genome, basically. So there's kind of nowhere else to go. It's reached the sort of ceiling. Most of the other traits that I showed are way, 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 way down from that, for a number of reasons, like they're much less easily and much less reliably measured than something like height. So for all of the ones that are included in these studies, there's enough signal for us to expect to be able to see something in most cases, if it's there. But I would never have confidence that what we're seeing is a good estimate of the size of a true effect. So it's more, they're more used in a way to kind of try and detect if something is there as a mechanism. But then if we observe something as a mechanism, then I wouldn't sort of say, and we know that it explains X proportion of the variation. The more recent, these models are a bit different. They take all the variability in the genome and partition things accordingly. So here you're not really missing anything in terms of the size of effects. But yeah, it's a good point that for anything including the polygenic scores, there's a lot of variation between the different traits about how well we know about the links between genes and traits. Yeah.
I was very interested in this concept of genetic nurturing, what you were talking about. I was wondering whether you think that the type of bonding that the parents have with the children bears an effect on that, whether it's a stable one or an unstable one, which, it's sort of fear in children, whether that affects the information which is coming through.
Yeah.
Or not.
Yeah, I think that's a really good suggestion of a mechanism. I mean, my view is that I haven't seen any evidence of a complex behavioral trait that is not under some form of genetic influence, right? And there are a number of complex behavioral traits that would, I think, go into a bonding from the perspective of both partners, but if we focus on the mother. So I think that it's completely plausible to me that if you're seeing a genetic nurture pathway in some association, that part of that may be through the way that a bond is built between mother and child. I think that, to put it another way, if bonding is a significant exposure for a given outcome, or if the quality of a parent-child bond is a causal factor in what happens in the child's outcome, then I would think that would lead to a genetic nurture pathway being seen in these kinds of studies, because I think that it's almost certain that the behaviours that go into bonding on the part of the mother are to some extent genetically influenced. Yeah. Okay. Yeah.
Maybe I just misunderstood something, but I wanted to ask if what indirect effects, genetic effects.
Yeah.
What exactly, for example?
It's a really good question. It's great that you asked it right after that one, because the answer is they're basically the same as genetic nurture effects, but people frustratingly use different words for the same thing. So, and I really should have explained that, so thanks for bringing that up. So when we talk about direct genetic effects, we're talking about and we really shouldn't even call them effects, right? We're talking about the association between variation in an individual's own genotype and their own behaviors. When we talk about indirect genetic effects, we're talking about associations between related family members' genotypes and the individual, the offspring usually's behavior, once accounting for those direct effects. Does that make sense? So it is really confusing, and I don't think we've really landed on good terminology. I don't love genetic nurture. I think indirect genetic effects is a bit confusing. So there isn't a great way. I mean, I think one way to think about them is environmentally mediated genetic effects, right? To the extent that family members are an environment, it's a genetic effect from somebody's genes that comes via an environment, not just being biologically expressed. Yeah. Okay. Right. Last section of the talk, and I won't take too much more time. But what I'm going to do is hopefully bring together some of those ideas by giving you a kind of case study. So now we're going kind of deeper, less broad, and talking about a specific question and how you might answer that using these methods. So this actually, the sort of true story about this is that it came about based on a comment that we received in response to the very first paper that I showed you on maternal prenatal depressive symptoms. And somebody said to us, oh yeah, well, interesting, you know, it's all genetically confounded when it comes to the relationship between prenatal depressive symptoms and offspring behavioural problems. But it's not really the depressive symptoms, it's actually, what if it's stress, you know, what if it's the fact that actually the mother is under stress? And maybe for some mothers, that doesn't result in depressive symptoms, but actually biologically, there's a stress response that is passed on in utero and has some kind of effect on the child later in life. And that's a kind of fair criticism or a fair kind of conjecture, we thought. And so then we thought, well, can we look at that? And it's also based in the literature, right? So there is a lot of evidence observationally linking prenatal stress exposure and behavioural and emotional problems in early childhood. So this is a kind of quite recent, last year, systematic review and meta-analysis of observational studies. And this was a quote from the thing. So psychological distress during the pregnancy period uniquely increases children's risk for aggressive, disinhibited and impulsive behaviours. And there are similar statements out there for emotional problems in the children. And I'm sort of hoping that from the sort of 50 minutes of priming that I've just given you, you're a bit concerned about the sort of strength of the causal language here based on all those other pathways we looked at, right? So this is just a review of observational observational associations, and actually what's being said is that this is a uniquely kind of increasing risk factor. It's very much flirting with like causal language, I would say. And maybe it is the case, right? Maybe it is the case that it's a causal risk factor to be exposed to that intrauterine environment, which is influenced by a biological response to stress. I think it's plausible. I think it's a plausible mechanism. So this is the research question then. Does it represent a causal risk factor for these childhood outcomes? So we decided to throw everything at it. Like, let's see if we can test this in different ways, different methods which have assumptions that don't overlap with one another, so that we don't end up in a position where we're saying, well, we don't really see it, but it could just be because of X, Y, Z. So I'm going to go through these different methods and what they test. So here's the central relationship, the causal relationship we're interested in testing. Maternal prenatal stress affects the intrauterine environment, that affects the child in life. So this is how this is measured. It's important to sort of bear in mind that these are quite sort of normative measures of stress, right? We're not talking about really awful things. We're talking about work stress, stressful life events, and stress in a relationship. And for the child outcomes, we go back to these same emotional behavioural problem items that I presented on in the first paper, but we also thought, well, we're throwing everything at this. We want to be able to show if there is a mechanism here, we want it to show up in this. So what we did is take also birth weight and gestational age, because the idea is those are kind of the first measurable phenotypes for the child, measurable traits for the child, right? If there is some effect of the intrauterine environment of maternal stress via the intrauterine environment on the child, we would expect to be able to pick it up in those measurements. So we include those as outcomes as well. So the first thing we do is a family model, sibling control. Do children in the same family or born to the same mother who are differentially exposed to these stressors, because two different pregnancies, do they have a different response to, do they have different outcomes, right? What this sibling control design does is account for some of these confounding pathways, right? If, for example, there's confounding via mother's genetics, well, mother's genetics don't change from pregnancy to pregnancy. The household, the environment, there may be some changes, but broadly speaking, lots of the macro environmental factors remain the same. So a sibling control design allows us to do that. Next, this one's a bit of a kind of, you have to think a bit laterally, but the idea is if this pathway exists and we have some measure of stress responsivity in mothers, then more sensitive to stress mothers should have children with worse outcomes relative to their level of exposure, right? And so what we do here is we take some polygenic scores, so like some measures of genetic liability to anxiety, to neuroticism, to ADHD, to PTSD, and we ask whether those mothers with high genetic liability for neuroticism, ADHD, PTSD, do they have a kind of, is there a stronger link in those mothers? Because if this was a causal association, then that is a plausible mechanism. If this link was going via one of these confounding pathways, then it's hard to see how the mother's sensitivity to stress could get involved. Next one, the intergenerational Mendelian randomization, the kind of nightmare one to get your head around. What we're saying here is if we can proxy maternal stress during pregnancy with some genetic instrument that is robustly related to stress and can't plausibly affect the child outcome via some other route, then we have a way of testing this causal model. So what we do is we take genetic variants in the mother that are associated with cortisol, which is a kind of stress hormone, and ask whether if we control for the effects of those variants in the child themselves and in the father to block any other factor or pathways, do we see an effect that is consistent with a causal exposure down here. And the final one, which I think is like a nice tonic to having to get your head around this, is a negative control, right? If the exposure happens after the outcome, it can't be a cause. So we just take measures of maternal stress from later in the child's life than the outcome is measured. Those measures of maternal stress are likely to share lots of kind of confounding with the exposure, but they're not plausible causes. So for this one, what we would do is compare associations between this and the outcome and between this and the outcome, and to the extent that they are similar, that's evidence of confounding, right? Because this cannot possibly be a cause of this. So if we see the same level of association here as we do here, that's a bad sign for this mechanism being a causal exposure. This approach of using different methods to ask the same question is known as triangulation. So this is like to try and get at a true answer to a question without being sort of hamstrung by particular biases or shortcomings, as much as you can. There are still biases and shortcomings. Okay, so results. Sibling control. So this is before we do anything with the siblings. This is the unadjusted effect, right? So this is equivalent to the observational effect. What do we see? We see that stressful life events during pregnancy are associated with more emotional problems at year and a half, 3 years, and 5 years. More behavioural problems at the same ages. They're not really associated with the birth outcomes. Relationship problems during pregnancy associated with more emotional behavioural problems. Work stress during pregnancy associated with more emotional behavioural problems and with earlier birth and lower birth weight over there. Okay, so this is like the unadjusted, we haven't done anything, the kind of estimates that would have been included in that systematic review and meta-analysis and would have contributed, as you can see, to this idea that, yeah, there's something going on here. We take siblings who have been differentially exposed, we adjust for the confounding structures, for the things that are shared within families, and there's a pretty clear pattern of these adjusted results being a lot closer to nothing going on, right? There's some sort of weird over-adjustment here, it seems, but if you take it in the round, I think it's pretty clear that what we're seeing is once you account for factors that are consistent across pregnancies for a mother, everything goes away.
Can I have a question? The siblings,
Yes.
are they younger or older?
A mixture. Yeah.
And was there a comparison of whether there was a younger or an older?
I can't remember is the unsatisfying answer. I'm not sure. I think we possibly did just control for parity, which would account for that, but I don't remember fully, so sorry about that. Okay, next method, polygenic G/E. So this is this idea by, like, if there's a causal mechanism, then should genetic sensitivity to the environment make a difference? No, it doesn't. So there's no evidence here. So we include height as a negative control here, right? So if there was something going on, we would expect that your genetic liability for one of these things on the part of the mother might be more associated with the link, or might enhance the link between the exposure and the outcome more than something completely generic like height. And it's just, there's nothing across the board. Intergenerational Mendelian randomization. No consistent associations between maternal genetic variants linked to plasma cortisol, a stress hormone, and the child outcomes once we account for the child's own genetics. And then the final one, the negative control. So this is, again, our observational associations. We can't do it for everything because we don't have good negative control exposures for everything. What am I missing? Work stress is not measured later in life. So these are just the ones where we have measures both during pregnancy and later in life, the child's life. So these are the observational associations, relationship problems associated with more behavioral and emotional problems, life events associated with birth weight, gestational age, and behavioral and emotional problems. Pretty much the same picture if the exposure is measured after the outcome. So this is not very consistent with a causal approach, right? A causal mechanism. If there was a true causal mechanism, we would expect something more like we kind of see if we squint a bit here, which is that the exposure outcome association is stronger than the negative control version. So altogether, maternal prenatal stress was observationally associated with the outcomes, as we saw, but there was no evidence across any of our methods which used different sets of assumptions to try and get at this mechanism that this is consistent with a causal explanation. So the implications of this are, I think, a challenge to the idea that that's encapsulated in something called the fetal programming hypothesis, sometimes called developmental origins of health and disease. This idea that what happens to you in utero is kind of critically important for your psychological, emotional development later in life. There are some caveats, right? I think definitely the fact that we're just talking about some quite normative stressors in a quite healthy, well-educated, well-off population is relevant to consider. I do think there's a plausible mechanism for people caught up in extreme environmental situations that there could be some kind of intrauterine effect. And I've said that about MOBA, and yeah, I think that there are possibilities that this mechanism exists, but I think how we've presented this is it suggests that there are some bounds on this mechanism, right? This isn't a ubiquitous process that happens across the distribution of stressors. Okay, I'm nearly done. You'll be pleased to hear. So overall, I think I've tried to show you that these associations, intergenerational associations, are really simple at the top level and then really complicated underneath, and we have to be aware of that complexity, because if we aren't, then we risk being misled in some quite sort of substantial ways. Trying to find the effects of the environment in these intergenerational transmission processes is quite tricky, and it's one of those things where it's very plausible, and I do believe that there are environmental effects, but they're kind of quite hard to pin down. And I think I would definitely sort of recommend this idea of trying to think of different ways to ask the same question in order to sort of really convince ourselves that we've done what we can to kind of avoid being misled. That's it. Thank you very much.
That was really terrific. Thanks so much for breaking it down. Really, really nice piece of methods, all sort of coming together. Very complex problems. So for people who want to stay and ask questions, please feel free to do so.
And the implication is for people who want to leave, please feel free to do so as well.
Unsafe.
Yeah. I'm going to say that.
Any questions?
So there might be a pathway effect, for example, mothers and babies.
Yeah. Yes. So yes and no. I think that's a good question. So in one of the studies that I showed, we looked at.
Laurie,
yeah.
could you shout out what the question?
Yeah. Sorry, I will. Yeah. So the question was about the genetic nurture effects and whether or not there are potentially effects between the partners, right? So where I think the example you gave is the mother's behaviour affects the father, and then that's the behaviour that affects the child. And the question is like, do we kind of control for that? Can we look at that? And I sort of said, well, in some cases yes, and in some cases no. And I think that a lot of the time we would miss the nuance in those mechanisms. But for example, in the study I showed where they looked at genetic liabilities on the part of the mother and whether they were associated with her behaviours and exposures during pregnancy, I sort of said ignore the fathers, but the fathers were there, and part of the reason the fathers were there was because fathers are often used as like a negative control in that situation where we say, well, it's an in utero exposure, so as long as we include the fathers as well, we can check whether, if there's no association between the father, then we're fine. But actually in that case, the father's genetics were associated with many of the exposures on the part of the mother. And I think it's not exactly the example you gave, but it's definitely a version of that where actually you can't treat them as kind of separate entities at all. And I think that there is that kind of interaction, and it's tricky to try and pull that apart, usually because of like mundane things like statistical power. It's hard to kind of get at that, but yeah, I would probably buy that those mechanisms exist. Yeah, thanks.
Cool.
Thanks, Laurie. It was great talk. So, I had two questions, if that's all right. One of them was about the antenatal depression, prenatal depression effect. I thought it was really fascinating, and it's sort of, to be honest, fits with some of the studies we've done before, just phenotypically. Like if you if you look at prenatal depression and then you just control for postnatal depression, often the prenatal effects just disappear. And we've also found that the closer to, again, it makes sense, the closer to the outcome you measure the depression in the postnatal environment, the stronger the association. So it all seems logical. I was just wondering, in that model that you presented, you showed really nicely how if you control for the genetic pathways, then the antenatal effect just disappears altogether. And that there's a residual effect from postnatal depression to the child's outcome. Can you disaggregate that into genetic confounding and direct transmission as well?
That's a really good question. I think you could. Those models are like fiendishly complicated, and by the time you get to that association, I'll probably get back to it if I scroll very fast. By the time you get to that association, there's not much left to decompose. So I can't remember exactly, let's find it there. That's true actually. So there's more of an association here, right? So we kind of like almost over control. But yeah, so you could, whether you could do it in the same model, I don't know. It gets a bit sort of wobbly when you have it there.
Then I have another slightly more kind of wacky question, which was, I in a lot of these studies where you're controlling for genetic confounders, the story is always, the assumed kind of environmental mechanism like antenatal stress disappears when you control for these genetic confounds, and that's obviously really important to know. I'm often left, and it probably relates to your point about power and so forth, I'm often left with the kind of lurking worry that, you control out so much that you don't detect real transmission effects or real causal effects. And I was just trying to think, are there examples out there where there's a known causal effect, where you can show that a model like this does indeed pick it up? I was struggling to think of any, but I suppose fetal alcohol syndrome or something like that. Yeah. A known causal mechanism, and does it actually correctly detect it when it's there?
Yeah. So one example is maternal drinking behaviours in MOBA, not during pregnancy, but during the early life of the child. You can run these models and still have a small but sort of significant effect of exposure to maternal called at-risk or risky drinking behaviours. But it is quite there's not much around, and that's kind of my point about how I think the risk is coming across saying there are no environmental effects, everything is genetic, and I don't believe that, and I would love more examples to be able to say, well, this is not least because I'm interested in, for example, the G by E stuff, right? So if you have an exposure like that where it's robustly associated once you account for the confounding, then you can get into this question of, well, does it matter, on the part of the child, their genetic sensitivity? If they're more sensitive to the environment, do they get more of a kind of problems associated with a particular exposure? And we actually tried that for the maternal drinking because it kind of existed as a robust effect, but it was so small that actually we couldn't really see much in the G by E. I think the problem is to do with the environments that we measure and how we measure them. So from the history of twin literature, a lot of what we get is genetics and non-shared environment, which is unsystematic environment that isn't captured by the things that we typically put in questionnaires. And it's the big question, what that actually represents and whether we could measure it if we did it better. So I kind of agree with you, and I'm quite glad that you mentioned it, because when I give talks like this, I don't want to come across as saying it's all genetic and exactly, because it's kind of genetics are not don't mean determinism, but there is a degree to which an environmental influence that we know about is much easier to intervene on and modify than a genetic one. So yeah, it's I think those examples probably do exist more widely than I've presented, but not that widely. Honestly, yeah.
Really interesting things. I just wondered how you would square, especially the last study about stress in utero with the animal work that shows that does have quite strong effects and they're very genetically smaller.
Yeah.
Tightly controlled.
Yeah, that's a really good question. I mean, honestly, I think that it probably comes back to the type of exposure and like what does, I don't know the animal literature to know well enough what they're doing to the mum rats, but like what's the equivalent of what they're doing, and is it captured in like stress in your day-to-day life and that kind of thing. Like I think that you get, this is just my kind of hunch, is that you get those effects by quite extreme stress in quite a controlled environment, and that in the real world of everything else, they sort of wash out much more easily. So I would think that that's probably what explains that, but I don't know for sure. Yeah.
Sort of a similar question. Do you know of any studies where they measure cortisol sort of periodically during the pregnancy to see how strong that effect is? So directly measuring it instead of through a questionnaire or something.
Yeah, so there's a study called Born in Bradford, a cohort in Bradford that do measure cortisol during pregnancy. I don't know if they did it on multiple occasions, and I don't know whether they've looked at the kind of observational association with that measured cortisol and the kind of child outcomes. I mean, one of the reasons why cortisol is not a great, and one of the limitations of that method as applied there is not a great indicator of this mechanism, is that I think there's quite a lot of evidence that the fetus is quite well protected from cortisol in particular. So we're having to assume that cortisol is sort of representative of stress, and that the actual exposure effect comes through some of the other consequences of stress. So there's quite a lot of sort of assumptions built on one another for that particular one. So I would say that, like, yeah, even in the case where you have directly measured cortisol, it's probably not that per se that you actually care about for this mechanism. I don't think. Yeah.
Makes sense.
Yeah.
Also a question about this work. Did you fit the model A essentially here, but instead of the maternal prenatal depression symptom, just plug in the co-current maternal depression symptoms to try to not accounting for.
Yeah, I think that was Pasco's question. Yeah, and that has been run on its own. So as you say, model A, but with concurrent depressive symptoms, that has definitely been run and published on. And honestly, I can't remember. I think that there is a lot of genetic confounding and a small residual effect. And the problem with that residual effect is that you've got mothers reporting on their own depressive symptoms and their children's problems effectively at the same time. And so there's, I think, a good chance that some of that is like shared method variance when we do that. And it was why I was kind of thinking about, well, could you do it at the same time? So could you model both processes at once, which I think was the question there. And that would be kind of interesting, but I don't know whether or not we could do that.
And just one other, I think you fixed the correlation between maternal-paternal genetics to 0.5, or maternal-child genetics to 0.5. Though assortative mating should inflate that slightly. Have you tried varying that parameter a bit?
Not varying that parameter, but like, believe it or not, some people have sought to make this model more complicated, like considerably more complicated, and in that they have modelled estimated assortative mating. Yeah. So then that accounts for the effect of that on the thing. And you're absolutely right. Well, the effect of the assortative mating, if it's there for a given trait, would be to inflate that.
So did the residual effect survive the...
So I don't think that extended model has been applied to these phenotypes, but it has been developed in terms of the model. Yeah.
According to this complexity of the eventual mediated genetic effects, I've read a few studies where they look at the epigenetics, and it seems to me that they can explain a few things that way. That are sure it's coming from the genetics, but the epigenetics can actually change through environmental responses and remain sort of fairly stable as well. I don't know whether you've come across that.
Yeah, I mean, the way I think about epigenetics is it's a kind of endophenotype, as in like it's somewhere on a pathway, right? And it's either on a pathway between the environment and, so the environment affects the epigenetic regulation of genetics, which affects some trait, or also other genes have influences on epigenetic regulation of other genes, if you know what I mean. So it can just be a genetic effect that comes from somewhere else, goes through the epigenetic regulation, and then comes out, in which case really all you need to know about is this gene and this outcome and their association. So I think that you're right that it's probably involved, but it's likely that we're not missing anything by not sort of accounting for it, because it's just somewhere on a pathway where we already have the information mostly, yeah.
Yes. I wonder if any of the models, including the NEL model that you just mentioned, so basically it models concurrent stress, I kind of have the feeling that the prenatal stress to the mother can somehow be linked to the concurrent stress, in that, for example, the mother is just susceptible to stress. How do we account for that, or to prevent overcorrecting, for example?
So the final kind of the negative control model in the final example that I presented is, I think, doing what you're asking, but then maybe it's not. So here we're sort of saying that we sort of want to capitalize on the fact that later stress likely shares a lot with prenatal stress, and so we kind of use that fact and say, actually, we want to get everything that it shares and ask whether that